Through the use of LiDAR, they have discovered that there are enormous structures underneath the Great Pyramid that go kilometers deep into the earth with coils.
Forget everything you were taught in middle school history class about gilded coffins and tomb robbers. For decades, we were told the Giza Plateau was nothing more than a glorified, ultra-expensive ancient graveyard. But when cutting-edge satellite imaging and deep penetration radar finally peered through half a mile of solid limestone, they didn't just find buried dirt. They found an interconnected, impossibly symmetrical grid of plunging spiral shafts and subterranean power vaults. The lost Egyptian machine buried under the pyramids had finally been rediscovered, and it looks less like a resting place for dead pharaohs and a lot more like a planetary engine waiting to be understood. Day of rediscovery. Let's be completely honest for a second. Deep down, nobody ever fully bought the official story about the pyramids. You walk up to the Giza Plateau, look up at millions of multi-ton blocks fitted together with surgical precision, and you are expected to nod along while someone tells you it was all carved with copper chisels and pulled up mud ramps just to bury one guy. It always felt like a massive mismatch between the sheer, terrifying scale of the build and the explanation we were given. But for over a century, if you questioned that script, you were told to sit down and let the experts handle the narrative. That all shattered on the exact day advanced space-age tech stopped asking for permission and started looking straight through the stone. When researchers finally pointed to modern satellite synthetic aperture radar and orbital vibrometry systems at the Giza Plateau, they weren't looking for ancient pottery or stray gold coins. They were using sensors sensitive enough to read sub-millimeter vibrations on the Earth's surface, translating the acoustic resonance bouncing out of the ground into high-definition subsurface maps. What lit up on their monitors didn't look like natural limestone fissures, and it certainly didn't look like primitive burial pits. Plunging over 2,000 feet into the solid bedrock, straight past the level of any known tomb, was a massive, perfectly lined network of subterranean infrastructure. We are talking about 8 identical subterranean spiral shafts carved in geometric symmetry, dropping down into massive, blocky underground chambers that look more like the blueprint of an industrial power facility than a place for mummies. That exact moment changed everything. That was the day the lost Egyptian machine buried under the pyramids moved out of the realm of fringe late-night conversation and slammed right onto the table of modern structural physics. The machine buried had been rediscovered, not by an archaeologist swinging a pickaxe in a cloud of dust, but by orbital arrays reading the subterranean pulse of the planet itself. To understand why this discovery sent shockwaves through the engineering world, you have to appreciate the sheer absurdity of the depth and precision we are dealing with here. A depth of 2,000 feet into solid, monolithic limestone is not something you casually chip away at because a pharaoh had a sudden artistic vision. That is deep crust excavation. That is the kind of depth modern mining conglomerates reach only when they are deploying heavy-duty, industrial boring equipment and explosive charges. Yet down there, hidden beneath half a mile of prehistoric rock, sits an interconnected web of vertical conduits and horizontal vaults laid out with mathematical perfection. The immediate realization was staggering. The famous monuments sitting above ground, the Great Pyramid, Khafra, Menkaura, aren't isolated, individual tombs standing proudly on a hill. They are the surface-level terminals. They are the massive, stone-capped exhaust ports and tuning forks of a vast, integrated subterranean engine. The massive stone pyramids we've been photographing for 100 years are basically just the visible tip of an absolute monster of an underground mechanical complex. When you look at the scans of this rediscovered layout, the traditional tomb theory completely crumbles under its own weight. Why would any civilization expend 90% of its total structural labor carving out hyper-symmetrical, non-funerary spiral shafts half a mile into the earth, filling them with geometric conduits? only to seal them up and never put a single body inside. You wouldn't. You only build like that if the geometry itself does a specific job. You only carve shafts like that if something, be it fluid, frequency, acoustic energy, or electromagnetic force, is supposed to move through them at high pressure. The day of this rediscovery didn't just add a new chapter to Egyptian history. It threw out the entire book. It forced us to confront a wildly uncomfortable possibility that thousands of years ago, on the banks of the Nile, someone constructed a monumental, planet-anchored machine designed to interact with the physical forces of the Earth itself. The surface pyramids were just the grand facade, while the real action was happening deep below, locked away in the dark, humming silently through the bedrock. Can a structure designed over 4 millennia ago truly function as a piece of planetary engineering? The subterranean architecture, geometry of a mega-mechanism. When you examine the raw geometric blueprint uncovered beneath Giza, you quickly realize this wasn't designed by artists or tomb builders. It was laid out with the strict, brutal logic of a high-end mechanical engine. Nature simply does not carve straight lines, hyper-precise angles, or identical repeating chambers. When geological forces fracture rock, they create chaotic, jagged, unpredictable cracks. But the radar scans pulled from the bedrock beneath Khafra and Menkaure reveal something radically different. Absolute, unyielding geometric symmetry. At the heart of this subterranean map sit 8 massive, vertical, cylinder-shaped shafts, plunging more than 2,100 feet straight into the Earth. Each individual shaft isn't just a vertical drop. It is wrapped in an intricate, continuous spiral pathway that corkscrews around the central conduit from top to bottom. Think about that design for a second. If you are building a simple air vent, access shaft, or ceremonial passage, a tight spiral wrapping around a vertical cylinder is the hardest possible shape to carve out of solid limestone. But if you are designing an industrial fluid conduit, an acoustic waveguide, or a particle accelerator component, that exact helical wrap is fundamental. Spiral geometry is how modern mechanics manage pressure differential, control vortex flow, and amplify kinetic energy in moving fluids and sound waves. These 8 spiral shafts don't just dead-end into blank rock either. They act as feeder lines, connecting directly into 2 colossal, 90-meter cube-shaped subterranean chambers. Above these massive vaults sit 5 additional multi-level structural tiers, all linked together by precise horizontal conduits and pressure relief channels. When electrical and mechanical engineers look at this specific spatial arrangement, they don't see a royal mausoleum. They see an unmistakable system layout, an array of vertical resonance shafts feeding into heavy-duty storage vaults and distribution manifolds. What makes this blueprint even more mind-bending is its strict adherence to sacred geometry and golden ratios. In modern engineering, we know that certain spatial proportions naturally minimize energy loss and eliminate turbulence. When sound or electromagnetic waves travel through a container, specific dimensional ratios allow the waves to bounce off walls and reinforce themselves instead of canceling out. The subterranean chambers beneath Giza utilize these exact proportions. Every shaft, chamber, and connecting duct is tuned like an instrument to sustain and magnify resonance. The lost machine buried under the pyramids relies on this geometry to achieve what modern physics calls constructive wave interference. The rediscovery of these subterranean spaces showed us that the surface pyramids were never meant to stand alone. They are merely the upper acoustic and mechanical caps of a megastructure that extends 10 times deeper into the Earth than anyone previously imagined. The pyramids on top act as impedance-matching transformers, capturing the vibrations generated down in the 2,100-foot deep spiral engine room and channeling them upward into the atmosphere. Every piece of this underground layout serves a functional, hydrodynamic, or acoustic role. The spiral pathways create controlled fluid rotational dynamics, The cubic vaults serve as primary compression chambers. The multi-tiered upper rooms function as harmonic filters and frequency regulators. It is a fully integrated closed-loop infrastructure engineered to handle immense physical forces without shaking itself apart. When you step back and look at the sheer scale of the blueprint, the intent becomes terrifyingly clear. Someone went to extraordinary lengths to carve a multi-tiered, mega-scale mechanical plant out of half a mile of solid rock. They didn't do it for aesthetics, and they certainly didn't do it for dead pharaohs. They built it because the geometry itself was the engine, designed to harness the raw kinetic and seismic power of the planet. The machine buried was built to run, and its layout was its operating system. If the layout mimics an engine, what materials were used to withstand its immense operational output? Anomalous precision and material science. To build a machine capable of withstanding massive mechanical, acoustic, and electrical stress, you can't just use any local stone. You need specific materials with unique physical, chemical, and piezoelectric properties. And when you look closely at both the surface monuments and the deep subterranean chambers of Giza, the material selection reveals a level of industrial material science that modern civil engineers can't help but respect. Whoever constructed the lost Egyptian machine didn't pick their stone based on what was easy to quarry. They transported millions of tons of high-grade rose granite from Aswan, over 500 miles up the Nile. Why go through the nightmare of moving massive multi-ton blocks of hard granite across half a continent when soft local limestone was everywhere? Because rose granite is packed with up to 55% quartz crystal. In modern technology, quartz crystal is fundamental to power and frequency control. Quartz is a naturally occurring piezoelectric material. When you apply mechanical pressure or physical vibration to a quartz crystal, it generates a precise electrical charge. Conversely, if you apply an electrical current to quartz, it vibrates at an exact, predictable frequency. By lining the inner core, the tension relief chambers, and the deep subterranean conduits with quartz-heavy granite, the builders weren't just making strong walls. They were building a massive, solid-state transducer capable of converting structural vibration directly into electrical and acoustic energy. The deep vaults and spiral shafts extend through layers of crystalline limestone, basalt, and dense quartzite. Basalt, an igneous rock formed from cooled lava, acts as a dense acoustic insulator and magnetic shield, containing energy within the internal chambers. Crystalline limestone serves as an acoustic conductor, allowing low-frequency earth vibrations to pass through with virtually zero attenuation. The strategic layering of these specific stones created an underground multi-material matrix engineered to manage high-pressure energy flow. Then there is the physical precision carved into these materials, evidence that leaves modern machinists staring in disbelief. Throughout the subterranean passages and surface blocks, you find drill core holes and saw cuts through solid granite and diorite that display mind-boggling feed rates. Helical drill grooves carved into quartz-hard granite reveal that the cutting tools were plunging into the stone at speeds hundreds of times faster than modern diamond-tipped industrial drills. The grooves show a uniform, relentless spiral pitch, proving that the tools weren't wobbling or struggling. They were slicing through stone like a hot knife through butter. Furthermore, the flat surfaces of the granite casing stones and internal vault blocks are finished to within thousandths of an inch of absolute optical flatness. You cannot achieve that level of surface accuracy by hand with copper chisels, wooden mallets, and sand abrasive. That level of tolerance requires precision surface grinding and optical-grade polishing equipment. The rediscovery of the lost machine forces us to reevaluate every physical block on the Giza Plateau. The subterranean shafts weren't lined with stone for decoration. They were insulated, shielded, and tuned with specific mineral compositions designed to handle intense pressure, continuous frequency vibration, and electrical discharge without cracking or degrading over time. Every granite slab and quartz block was a functional, heavy-duty component in an ultra-durable mechanical grid. Once the materials were set and the shafts were carved, what force was meant to flow through them? Power, sound, and resonance. The machine in operation. Once you have the subterranean architecture carved out of solid limestone and the vaults lined with quartz-rich granite, you have to ask the ultimate question: what actually happens when you turn this system on? The answer lies in the physics of acoustic resonance, infrasound, and telluric energy. The lost Egyptian machine wasn't powered by fossil fuels or steam. It was designed to run on the natural, ambient kinetic vibrations of the Earth itself. Our planet is never truly still. The crust is constantly humming with low-frequency seismic waves, tidal forces, and telluric electrical currents, natural electrical charges that flow continuously through the ground. At 2,100 feet beneath the Giza Plateau, the 8 spiral shafts drop directly into the Earth's natural stress zones. These deep vertical conduits act as massive acoustic pickups, gathering those deep Earth micro-seismic vibrations and funneling them upward toward the surface. As those low-frequency vibrations move up through the tight, helical wraps of the 8 spiral shafts, a powerful hydrodynamic and acoustic phenomenon takes over. The spiral geometry forces the incoming waves into a controlled vortex. Just like a hurricane gathers speed and intensity as its winds spin toward the eye, sound and kinetic energy compress and accelerate as they move through a helical conduit. By the time these vibrations reach the massive cubic subterranean vaults, their pressure and frequency have been amplified exponentially. This brings us to the principle of the Helmholtz resonator. In modern physics, a Helmholtz resonator is an enclosure with an opening, like blowing across the top of an empty glass bottle to produce a deep, ringing tone. The massive subterranean vaults beneath Khafra and Menkar function as giant, industrial-scale Helmholtz resonators tuned to specific low-frequency acoustic standing waves. As the compressed infrasound hits these quartz-lined cubic vaults, it subjects the granite blocks to intense, continuous physical stress. This is where the material science kicks in. Through the piezoelectric effect, the immense physical pressure bouncing off the quartz crystals inside the granite generates a steady stream of high-voltage electrical energy. The mechanical vibration of the Earth is directly converted into electromagnetic frequency. The lost machine, buried under the pyramids, was essentially a planetary energy transducer. It took raw, chaotic seismic noise from half a mile underground, organized it through sacred geometric spiral shafts, amplified it inside resonant acoustic vaults, and converted it into usable, coherent electromagnetic power. The pyramids sitting above ground were the final piece of the operational circuit. The Queen's Chamber and King's Chamber inside the Great Pyramid, for example, are laid out as precise acoustic resonators tuned to fundamental harmonic frequencies. The granite beams above the King's Chamber, often called relieving chambers, act as acoustic tuning forks that absorb, refine, and focus the rising energy. The entire pyramid structure acted as a massive wireless transmitter, projecting this converted acoustic and electromagnetic frequency upward into the ionosphere or across the regional landscape. When fully operational, the Giza Plateau would not have been a silent city of the dead. It would have been a vibrating, humming power grid. The ground beneath your feet would have pulsed with a deep, low-frequency infrasonic thrum, a frequency below human hearing, but powerful enough to shake the air, drive ambient energy through the airwaves, and stabilize regional seismic fault lines. The rediscovery of these 2,100-foot subterranean conduits finally gives us the intake manifold for that global power grid. It proves that the energy wasn't created on the surface. It was pulled from deep below. Yet, an engine of this magnitude requires a continuous fuel source, and nature supplied it right next door. The Nile, geology, and natural energy harnessing. An engine of this scale couldn't rely on dry rock alone. It needed a fluid dynamics catalyst to kickstart and sustain its operational cycle. That catalyst was water. Today, the Giza Plateau sits surrounded by dusty desert, but thousands of years ago, the landscape was radically different. Satellite mapping and hydrological core samples have confirmed the existence of the lost Aramat branch, an ancient, massive arm of the Nile River that flowed directly along the base of the Giza pyramids. The builders of the lost machine, buried under the pyramids, didn't just build near the river for convenient transport, they engineered a direct interface with it. Deep beneath the plateau lies an intricate network of subterranean aqueducts, stone-lined channels, and natural limestone karst aquifers. When the Nile flooded annually, millions of tons of water rushed into these underground stone tunnels, creating an intense, self-sustaining hydraulic system right above the deep 2,100-foot spiral shafts. This layout operates on the principle of a hydraulic ram pump. When a large volume of moving water is suddenly forced into a narrowing underground stone channel, the kinetic energy of the fluid builds up immense shock waves, a phenomenon known as fluid hammer. As water slammed through the lower chambers beneath Giza, it created rapid, high-pressure pulses of kinetic force. These water surges acted like giant pistons, pumping compressed air and heavy vibrational waves directly into the subterranean spiral conduits. Furthermore, the interaction between water and limestone creates a natural electrochemical environment. As underground water flows rapidly through porous, mineral-rich limestone channels, it generates a phenomenon called streaming potential, a subtle but continuous flow of electrical current produced by fluid friction against stone walls. The water wasn't just driving mechanical vibrations, it was charging the surrounding bedrock with continuous static electricity. The deep spiral shafts discovered under Giza were strategically placed to capture both this hydraulic energy from above and the deep seismic vibrations from below. The water flowing through the upper aqueducts created a continuous acoustic pulse that traveled downward, meeting the rising infrasonic waves coming up from the deep crust limestone layers. Where these two forces met inside the cubic vaults, they created a stable, self-amplifying resonance loop. This hydrological integration also served a vital cooling and dampening function. Any high-output machine converting massive kinetic and acoustic forces into electromagnetic energy generates immense internal heat and structural stress. By routing subterranean river channels around the core vaults, the builders created a natural water cooling jacket and a hydraulic shock absorber, preventing the quartz-lined granite chambers from shattering under their own operational pressure. The Egyptian machine buried under the pyramids was entirely green, self-renewing, and anchored into the natural metabolism of the planet. It harnessed the seasonal rise of the Nile, the natural flow of deep aquifers, and the constant tectonic pulse of the Earth's crust to generate power without ever burning a single lump of coal or oil. It was an absolute masterpiece of planetary engineering that turned nature's most basic elements, stone, water, and vibration, into a clean, perpetual power plant. With such compelling structural evidence, why does the scientific establishment remain so fiercely divided? The scholarly divide: archaeology versus advanced engineering. Despite the undeniable structural, materials-based, and geometric evidence carved into the bedrock beneath Giza, the academic world remains locked in a fierce, ideological battle over what these subterranean networks actually represent. On one side stands traditional Egyptology, rooted in a 19th century academic framework. On the other side stands a growing coalition of modern mechanical engineers, materials scientists, and geophysicists, who refuse to ignore the physical reality of the site. To understand why this divide is so bitter, you have to look at how history is written. Traditional archaeology is fundamentally a text and artifact-based discipline. For over a century, the golden rule of Egyptology has been that if you find a monument, it must be a tomb built for a pharaoh during a specific dynastic period. When traditional scholars look at the Giza Plateau, they see tombs, funerary temples, and mortuary complexes designed to ensure the ruler's passage into the afterlife. Because no dynastic papyrus explicitly details the construction of a 2,100-foot subterranean power grid, academic traditionalists simply declare that such a grid cannot exist. However, mechanical engineers look at the physical world through a completely different lens. A structural engineer does not care about hieroglyphs or royal cartouches when analyzing an underground shaft. They care about load tolerances, stress distribution, material hardness, and fluid dynamics. When an engineer examines the 8 spiral shafts and quartz-lined cubic vaults of the lost machine, they see a design language that has nothing to do with burials and everything to do with heavy-duty energy management. You do not carve a non-funerary, hyper-precise helical conduit half a mile into solid limestone just to leave it empty as a symbolic gesture for a dead pharaoh's soul. This clash of methodologies reached a breaking point with the day of the rediscovery, when satellite synthetic aperture radar and acoustic vibrometry forced non-invasive physics directly into the archaeological conversation. Non-invasive technology does not care about historical bias or preconceived timelines. The radar waves and orbital sensors simply measure physical density, spatial geometry, and acoustic resonance. When those sensors returned clean, unmistakable maps of 2,000-foot deep symmetrical infrastructure, the traditional tomb paradigm suffered a fatal blow. The core problem is that traditional archaeology often struggles to interpret non-textual, functional engineering. If a civilization built a machine out of stone rather than metal gears, standard history mistakes the machine for a primitive building. But as material science continues to advance, we are realizing that stone, specifically quartz, granite, basalt, and crystalline limestone, is the ultimate long-term engineering material. Metal rusts, degrades, and dissolves over centuries. But a stone machine built directly into the Earth's bedrock can survive for tens of thousands of years intact. The lost machine sits right at the center of this intellectual revolution. The scholarly divide is no longer just a friendly debate about ancient history. It is a fundamental collision between two different ways of looking at human capability. As more independent engineers, geophysicists, and physical scientists apply modern technology to Giza, the academic gatekeepers are finding it increasingly difficult to defend the primitive tomb narrative against the cold, hard, measurable reality of precision engineering. As the debate rages in academic halls, one final question remains unanswered beneath the stone. The silent network, global resonant nodes, and lost technological civilizations. Giza does not exist in an isolation chamber. When you map out the world's most baffling megalithic sites, a disturbing pattern emerges that standard history simply cannot explain. The 8 2,100-foot spiral shafts and quartz-lined cubic vaults discovered beneath the Giza Plateau mirror the exact acoustic, geometric, and electrical principles found underneath other ancient stone megastructures around the planet. From the subterranean liquid mercury chambers buried under the Sun Pyramid at Teotihuacan to the acoustic, sound-amplifying hypogeum of Hal Saflieni in Malta, ancient builders were obsessed with carving deep into crystalline bedrock. The lost machine was likely not a solitary experiment. It was the master control hub of a planetary-scale energy grid. When you analyze these global sites using modern geophysics, you find that many are situated precisely along major telluric current lines, the natural conductive fault lines of Earth's magnetosphere. Just as the Giza machine used its 2,000-foot vertical shafts to capture seismic vibration and stream electrical current, sites in Peru, Mexico, and China utilized hyperdense basalt, rose granite, and subterranean water channels to achieve the exact same piezoelectric resonance. They were all playing the same physics game, using the same material science, to achieve the same mechanical result. This suggests a terrifyingly radical possibility. Long before our recorded history began, a globally connected, highly advanced technological civilization spanned the Earth. They didn't build with fragile silicon microchips or wires that rust away into dust over a few millennia. They built a solid-state stone and frequency infrastructure built to survive cataclysms, ice ages, and tens of thousands of years of orbital shift. The day of rediscovery beneath Egypt didn't just reveal a local anomaly. It tapped us into a silent, forgotten global network. The deep spiral conduits beneath Khafra and Menkar were the central tuning forks of a planetary machine engineered to balance seismic stress, tap telluric currents, and transmit clean, wireless resonance across continents. The pyramids of Egypt were simply the most grand, resilient, and output-heavy transmission towers ever anchored into the crust of our planet. As we trace this silent planetary network, one final, fateful question hangs over the Giza Plateau. Reawakening the subterranean engine. We now stand at a historic crossroads. The rediscovery of the machine buried under the pyramids has permanently shattered the illusion that ancient humanity was primitive, limited to simple hand tools, and obsessed solely with death. When satellite synthetic aperture radar and acoustic vibrometry pulled back the curtain on half a mile of solid limestone, they revealed a non-funerary, hyper-symmetrical, 2,100-foot-deep megastructure that operates on the exact principles of modern mechanical, hydrodynamic, and acoustic physics. The ultimate question is no longer whether this subterranean machine exists. The geometric and material evidence carved into the bedrock makes its presence undeniable. The question now is, what do we do next? For the first time in human history, our own technology has advanced just enough to recognize the blueprint left behind beneath Giza. We have the non-invasive imaging, the material analysis, and the understanding of piezoelectric resonance needed to decode how this planetary engine once functioned. But modern science still hesitates at the edge of the physical abyss. Drilling down 2,000 feet directly into those pristine, quartz-lined cubic vaults to deploy physical sensors and robotic cameras would be the single most important archaeological and engineering expedition in human history. Imagine what awaits us down in those deep, silent shafts. Physical excavation could uncover preserved mechanical conduits, ancient material alloys, or direct physical proof of how energy was harvested, amplified, and transmitted wirelessly across the ancient world. Tapping into the secrets of the lost Egyptian machine could offer humanity a radically new perspective on clean, perpetual Earth-anchored energy. A blueprint for pulling power straight out of the natural seismic and hydrological metabolism of our planet without burning a single resource. The massive stone pyramids sitting on the surface of the Giza Plateau have kept their silence for thousands of years, acting as time capsules waiting for a civilization smart enough to look beneath the surface. Now that we have mapped the lost machine and rediscovered its subterranean architecture, the engine room sits right beneath our feet, cold and waiting in the dark. The blueprint is fully exposed. All that remains is for modern humanity to find the courage, dig beneath the limestone, and figure out how to turn it back on. The rediscovery of the subterranean machine buried under the pyramids has forever shifted our perspective on ancient history, proving that the Giza Plateau conceals a masterclass in planetary engineering. As modern science continues to map these deep quartz-lined shafts and resonant chambers, we move closer to unlocking secrets that could reshape our understanding of clean energy and lost human potential. The blueprint beneath the sand is finally clear, but the journey into its deepest vaults has only just begun. If you enjoyed exploring this video into ancient high technology, don't forget to subscribe for more fascinating investigations.